Okay, the next thing on tap is throttle control. Manual throttle linkage. Use direct linkage from the throttle to the throttle. Basic old cars, right? Look at this sweetheart. Here's the throttle bodies, our 6-packs. I think it's a 6-pack. And here's the throttle linkage. Here, here, and here. And you can see the throttle cable. That's mechanical. Electronic throttle control. Electronic throttle control uses a computer to control the throttle based off the APP signal, external pedal position signal. I'll show that later on. But here's a throttle. It's a basic all carburetors, all throttle bodies, all cars. The throttle controls the engine speed. This is the throttle plate, and creates a vacuum. Now, how does it create a vacuum? Because when this is on the car, one side is exposed to pressure, the other side is exposed to vacuum created by the pistons. Remember, your engine's a vacuum pump. While that car is running and this throttle plate is closed, pressure on one side, low pressure on the other side equals a vacuum. The low pressure air is a vacuum. So that throttle plate is actually creating a vacuum along with the pistons going up and down, or reciprocating. Back in the day, we used carburetors, right? All carburetors have a throttle. You see here, throttle plate, and here's the throttle. They usually have a mechanical linkage going to it. You can see here, throttle plate, throttle adjustment, throttle position sensor, throttle lever. Electronic throttle control, right? What this means is we got rid of the throttle cable. It stopped being mechanical now. Now it's controlled by the computer. And the reason they use this is for safety, enhances ABS and ASR, emissions, optimal throttle angle for better fuel control, or lower emissions, and economy, eliminates pumping loss. That's a drag on the engine. So the basis of the throttle, some of the reasons for the throttle control was safety, emissions, and fuel economy, and also eliminates pumping loss. What is pumping loss? Also known as engine deceleration and braking. Using the engine compression to drag down the vehicle. And you get very bad fuel economy when you do that. Now here's electronic throttle control. As you see here, this is electronic throttle control. You can see the consumer presses on the APP, the throttle. There's an APP sensor on there. No more linkage. It sends an electrical signal to the ECM. The ECM then turns around and sends a signal to the throttle control. You can see here, here's the throttle, here's the linkage, but there's no more cable. It's controlled by the computer, electronic throttle control. Here's the acceleration pedal position sensor. Before we used to step on the gas pedal, there was a cable. Now there's no cable. It's a sensor on some of the newer cars. When you hit the gas pedal, this sensor tells the computer you just touched the consumer just hit the gas pedal. It sends a signal to the computer sends a signal to the throttle, electronic throttle control, that opens this plate here. Remember, this plate control is for speed and also helps create vacuum. Now here is they also use redundant sensors, throttle position sensors, TP1 and TP2. Throttle position 1, throttle position 2. That's for safety and economy. Now I want you to look here. Electronic throttle control motor. Right? It's all in one assembly here. It's called electronic throttle control motor. Now the thing I want you to understand with this one, there is no idle air control motor. Everything is controlled by this unit here. Okay, so And what's the idle air control motor? I'll explain that later. It's idle air control. It's a motor to help maintain idle, like idle speed. But with electronic throttle control, they don't have that. The computer is controlling the throttle itself of inputs from the APP and TPS. Idle speed control, throttle openers, IAC valves, idle air control valves. You see a lot of these in the older cars. Throttle openers and idle air control valves over the fuel injection cars. Throttle openers, some fuel injection, but mostly older carbureted cars. Here's example 1. That's a throttle stop solenoid. So the car won't stall in carbureted cars. It's an ISC, idle speed control, a carbureted odd fuel injection cars. You see this right here. Throttle openers are plunger that actuates the throttle. An idle air control valve is a valve that controls a throttle bypass. This idle throttle opener is pretty simple. It's this right here. Idle speed control motor. Here's a plunger that catches the throttle. It readjusts by ratcheting back and forth to control the throttle lever here. And this is the cable that goes back to the gas pedal, which ETC gets rid of. Here's the idle air control. The ECM receives inputs from various sensors. It sends a signal down to the idle air control. The idle air control itself bypass air around the throttle plate to maintain the idle. You usually find that on fuel injection cars. It's actually a calibrated vacuum lead. Right? It controls a vacuum lead bypassing the throttle or going around the throttle to help maintain the idle. And over here is a fast idle thermal valve in some cars. In the morning you start your car up, you know they got a high speed. There's a valve that's doing that, especially on fuel injection cars. Now on an ETC, electronic throttle control, they don't have this because everything is controlled by the computer. The throttle is controlled by the computer. So this IAC valve is not there on the electronic throttle control systems. Now idle air control can be mechanical, right, bimetallic or thermal coupler, or electrical, speed motor, rotary valve, or solenoid, or a combination of both. So idle air control valve could be a mechanical function or electrical, or a combination of both. Here's a cold start valve, thermal valves. They use water. This one has a water passage, right, with bimetallic spring internally. This one also, I think there's a Volvo or Volkswagen on this one. Same concept. Stepper motors. This is under a stepper motor, but it's actually an IAC right here, idle air control motor. This one and this one. This one also. Well, I guess they ratchet. I guess it would be under the stepper motor category, but they are idle air control motors. Rotating valves. Rotary valves. This is a forward idle air control valve or idle bypass valve. They call it different types of solenoids. Multifunction valve controls idle speed and high speed. High RPMs. All right, so basically you can see the difference now. ATC is better for safety, fuel economy, and emissions. Okay, I said earlier they can be mechanical or electrical, but the ETC does not have an idle air control valve. They're controlled by the computer by inputs from the TPS 1 and 2 and AP sensors 1 and 2. And what else I want to review here? And also the throttle plate creates a vacuum. Pressure on one side, vacuum on the other side. It also controls idle speed. And you can see here, ETC, no cables, all electronic. Input to the ECM over to the electronic throttle control. Electronic throttle control again, safety, emissions, and fuel economy. And you can see on here, You got redundant sensors, and they leave out the idle air control motor. They had electronic throttle control motor instead. Okay, that's the basic setup. See you